Hello and welcome to Novatio Electronics Tutorials. I'm your host Morris Demar, and today in C language special functions we will look at getDigit. The getDigit function is a special function we create for solving the problem where you have a big value which consists of many other digits which represents various things, and you would like to abstract a particular digit out of that larger value to use. For example, in this case we've got a big value and we have a bunch of settings which we have connected to this value, like tracks, input selections, IDs, etc. So in this case we're going to use the ID, for example, which is the value 5, or our fourth digit. In order to solve this problem, we're going to define each position at the zero-based index. So the fourth digit is actually index 3. Now if we take that value divided by 10 3 times, then we will remove the last 3 digits, so we effectively shift it to the right 3 times, or 3 spaces. What we then need to do to get rid of the more significant digits is to divide the value by 10 once again, remove a 5 and multiply it by 10 again and replace it with a 0. So then in order to get the 5 on its own would be to subtract the 10th value from the value we have, and that will leave us with a 5. And this we can basically do to abstract almost any digit in that value. This is a very universal way of doing it, which does not require any dependencies on libraries, etc., where we can just use very plain algorithm procedural programming to solve this problem. For the code example, I'm just going to explain this quickly. We have an int at the top left hand side, which is the value which we're going to return, which is an integer value. We're going to call it getDigit. Then we're going to have an int value, which is the input value, that large number we want to abstract something from, and the next is also an integer for the position. Then we will have a while loop which will test for whether the position is bigger than 0. We will OR that with the value if it's bigger than 9. So what this basically means is that both these conditions has to be 0 in order for the while loop to terminate at the end of the day. If any of these two are not or still not met, then it will continue to stay in the while loop. So the first thing we do is to shift that value to the right hand side, and therefore we've started with if position greater than 0. Then what we do is to say value equals the value divided by 10, and then we decrement the position, because at the end of the day when the position reaches 0 we no longer want to continue dividing by 10, then we have shifted to the right enough positions. Once the shifting to the right has been completed, then the else command would take us to removing the more significant digits, and there we divide by 10 and make it equal to the 10th value as we explained earlier, and then we just take the 10th value and multiply it by 10 again, and then we have created a 0 as the least significant digit. When we take this value, subtract the new value with a 0 at the end, and it would give us a remainder of 5. The timeout I put in here because a while loop, when conditions is unfavorable, can potentially still run forever. So what we basically did is we defined a timeout, made it equal to 100, and when every time the while loop cycles, it deducts or decrements the timeout with 1 digit, 1 increment, and once timeout reaches 0 we will return a -1 indicating an error. Usually it should not run as much as 100. For most values are not that large, but it will run that much, maybe 5 to 10 times or whatever would be the typical amount of cycles. Once the while loop has terminated and both these conditions are 0, then return value, and that would now be the abstracted digit, like in this case 5. So let's see how we can test this code. We create a main routine. We define an input variable where we basically put our input value in, what we want. We define a value. This is just going to be the return digit. That's the digit we're going to get out of it. But we're going to start off by position 0, or with a value of 0 at position 0. And we define I just for the for loop. Now in the for loop, I've set it to do 12 iterations, although we only have, I think it's 1, 2, 3, 4, 5, 6, 7, 8, 9. We only have 9 digits. I've set this to 12. That means it's going to overrun. This is just to illustrate what would happen in case you use a position value larger than what is contained in that value, which is very possible. It might quite often happen depending on what settings and what values are involved in there. So the idea would be that it would just return a leading 0. So it will assume that if that input value is relatively small, all other values to the left hand side is leading zeros. So we run the for loop, and then we call the getDigit function we have just explained. We call the getDigit function, we provide the input, we provide the position. The position start off with being 0. Then we're going to print this value as position and whatever the position is, and then equals to the return value, and then just a next line escape character. Then we assign the position and the value. Once this is completed, we increment the position so that we can basically test what happens at position 0, what happens at position 1, what happens at position 2, what happens at position 3, and so on. So let's look at the results of this test. Our results have been position 1, position 2, position 3, position 4, and so on, and every time it returned a different digit until it got to 8, which is the 9th digit. Thereafter we start returning the leading zeros. So if the value we used in our example is what we have been using here, then our first digit 0 will be 3, then 7, then 2, then 5, 6, 8. So all this is accurate according to the example we've used, and we've got the leading zeros as expected. Thank you for listening to this episode. I hope this have helped someone. Please feel free to subscribe to my channel or leave a comment below.